All right, we are on 10-5, and 10-5 is all about surface area again. But this time we are talking about, last time we were talking about prisms. Remember, prisms are three-dimensional figures that have two congruent parallel bases. So I know these don't look parallel or congruent, but if these are the bases, these would have to be congruent and parallel. So we talked about prisms, we talked about rectangular prisms, and we also talked about triangular prisms. And then the last thing we talked about yesterday was cylinders. Cylinders and prisms use the same formula for surface area because they both have two congruent parallel bases. Today, we're not talking about prisms, we're talking about pyramids, and we're talking about cones. And the reasons why we're talking about pyramids and cones is because instead of having two bases, they only have one. So a pyramid has one base, and then they all meet up to a common vertex. And cones, same thing. Instead of having a shape, a polygon as their base, they have a circle as their base, and again, they come up to meet at a common vertex. So today we're talking about surface area of these two shapes. So for CP, you have these notes, and you're going to write down that a prism, again, is a three-dimensional figure. That's what we're talking about today. I don't know why I put prism, excuse me. Pyramid, cross that out, put pyramid, is a three-dimensional figure that has only one base that is a polygon. So it's not a circle, it could be a triangle, it could be a square, it could be a rectangle, it could be a hexagon, pentagon, nonagon. Okay, and we're finding surface area, that's the sum of all of the sides. So if we look at what surface area, again, like we talked about yesterday, is we're going to split it up into the base area and the lateral area. Remember, the base area is that polygon, either the triangle, the square, the hexagon, nonagon, whatever. The lateral area is the area of the sides, the shapes that are not the base. So let's say we take this pyramid. This is a square pyramid because all the sides at the base are congruent. This side's S, this side's S, this side's S, this side's S. Okay, so actually, I don't know why I said square. It could be a parallelogram. Anyways, so we have this pyramid. If you cut it up, if we cut it up and laid it flat, it would look like this. This is called a net. If we cut it up and laid it flat, this is what it would look like. So we want to know, we don't care about, we can figure out how to find the area of the base. We want to look at the sides now. If we laid them flat, we would have these four triangles, right? 1, 2, this side would be 3, and this side in the back would be 4. We have 4 triangles, and if you notice, this is one side of the pyramid, this is another side, so we have 4 sides of the pyramid, or the perimeter, if you will, of the base, much like what we did last time, times this part. Now this is called, this L stands for the slant height. So the L comes for the slant height part. We call it the slant height because the pyramid is slanted, right? It doesn't go straight up. The height, the regular height, would be perpendicular to the base. It would go through the pyramid and be from the vertex down to the base, and it would be inside the pyramid. The slant height is the height from the vertex to the side of the base. So this is on the outside. Slant height is on the outside of a pyramid or a cone. Okay, so we're going to take the slant height times the perimeter of the base, but that would get us this whole rectangle, and we don't have the whole rectangle, we only have half of the whole rectangle. So to find the lateral area of pyramids, because they only have one base, what you do is you take the perimeter of the base, like we did last time. This time, instead of multiplying it times the whole height, we're going to multiply it times the slant height, and that'll give us this whole rectangle. We only want half of it, so you can say half of it, or you know me, I like perimeter of the base times slant height and then just divide it by 2. Either works. So that's why I have written out for you guys who have this note-taking guide, CP. And these are the formulas we're going to use. This formula works for all figures with only one base. Okay, so CP, your problems are a little bit different, but it's the same setup. Rectangular prisms. Find the lateral area and surface area of a regular square pyramid. This tells you, remember, this tells you what shape the base is, with a base edge length 14 centimeters and slant height 25. Round to the nearest tenth if necessary. So the reason why I have these in words is because I want you to know how to draw the picture. So we know the base is a square. Oops, that doesn't look like a square. Okay, so we have a square. There it is, sweet. And all the sides are 14 centimeters. Then we know that they go up and they meet at a point, right? So it's like if we were looking down at our pyramid, that's what it would look like. And it says there's a slant height. This is hard for some people to visualize. Slant height goes from, again, it's on the outside. It's on the outside of this pyramid, and it goes from the vertex down to the side. And the slant height is 25 centimeters. Okay, so for the base area, all we have to do, the base area is a square, easy peasy. That's just base times height. And they're both 14, so 14 times 14, which is 196 square centimeters. Okay, lateral area. Remember, that's going to be half, not the whole thing, of the perimeter of the base times the slant height, not the regular height, which they don't even give us, so it's not a big deal. Okay, so perimeter of the base, we know that that's a square, and all the sides are 14. So we have 4 sides that are 14. That's going to be the perimeter of our base. So slant height is 25, and all we have to do is take half of it. So 4 times 14 times 25 is 1,400 divided by 2. I get 700 centimeters squared. And then the last thing we do to find the surface area is we take the base area. We take the lateral area, we add them up, and that'll get us our final answer. So 896 square centimeters is your surface area. All right, so honors, you're going to try the same one for number 2. CP, you're going to do the question that I give you on your paper. So if you notice, I gave you a rectangular. CP, do this question too. Okay? Don't worry about the ones I gave you. I don't know why I gave you those ones. CP, do this question, not the one I drew for you on your packet. Sorry about that. Okay, triangular pyramids. Triangular pyramids, you guessed it, have a triangular base. And so here's a picture. We have a triangular base, okay? And let's say I tell you that these sides are all 7. So it's an equilateral triangle. I'll be nice to you guys, and I'll even tell you that the height of this base is 6.1. Okay, so that's our base of our triangular pyramid. Now, what happens if we extend all these points up to one common vertex? Now we have a pyramid, and I'm going to tell you that the lateral slant height, so if I drew down here and I drew a perpendicular line to this side, this is going to be my slant height, and that's going to be 11.2. So slant height is 11.2. All right, so to find the surface area of this problem, first we're going to find the base area. The base area this time is a triangle. To find the area of a triangle, it's base times height divided by 2. Okay, so we know that for just looking at our base, I'm going to highlight it for you because some people are going to be confused by this picture. This is our base. So the base and the height, remember, are perpendicular. So that means that the base is going to be 7 and the height is going to be this 6.1. So we have 7 times 6.1 divided by 2. That's going to get us the area of this one base, and we only have one this time. So I get 21.35, and I didn't give you any units. So let's call it feet squared. Okay, feet. Sorry. Okay, that's the base area. CP, this is the picture you have on your packet. Lateral area, remember, it's half the perimeter of the base times the slant height. Okay, so if we still go back to this base, the perimeter, we have 3 sides that are 7. And the slant height is 11.2. So if we multiply all these together, 3 times 7 times 11.2 divided by 2, I get 117.5 10.6 feet squared. And then to find surface area, remember, we take the lateral area, we add it up with our base area, and we get that the final answer is 138.95 feet squared. Okay, now, if you're thinking, this is really easy, Miss Broyles, come on, give me a challenge. Well, don't you worry, I will give you a challenge. Because how could I make these questions harder? What happens if I don't give you the slant height? So tomorrow, in class, we're gonna talk about problems that occur if I don't give you the slant height. How can we find it? Hint, hint, Pythagorean theorem. Okay, number 4, CP honors. You guys are going to do this one on your own. CP, do the ones that I gave you on your packet. 4 honors. Let me draw it for you as best I know how to. This is a triangular pyramid, so the base, I'll highlight it for you. This thing right here, that's our base, and it's a triangle, and the sides are all 12. That's all I'm going to give you about the base, honors. Because if all the sides are the same, what kind of triangle is it? And then if we cut it in half, what special right triangle do we get? Hint, hint, wink, wink, 30, 60, 90. Okay, and then honors, I'll be nice, and I'll let you know that the slant height is going to be 10.6 meters. Okay, so that's the slant height. All right, so you guys can find this surface area. The next video, we're going to talk about cones. So much easier than pyramids.